Students, this question was asked in NEET exam 1994 from chapter 5 of class 11, that is from the chapter of work, energy and power. When a body moves with a constant speed along a circle, what happens? There are four options given. No work is done on it, no acceleration is produced in it, its velocity remains constant, no force acts on it. Students, let us draw the situation. Suppose a body is moving along a circle. Suppose this is the body. Okay. Suppose at this time the body is here. Then the velocity is directed like this, and the direction of the velocity is here like this. The direction of the velocity is here in this direction. The direction of the velocity is in the direction. Its magnitude may be constant because it is given that it travels with constant speed. It rotates with constant speed, means its magnitude is velocity. The magnitude of the velocity is called the speed. What is velocity, students? We know v is equal to dr by dt, or the rate of change of this the position vector of the body, or the time of change of displacement is called velocity. And the distance traversed by a body divided by time, or how much distance is traversed by a body in a time, is called its speed. Speed is a scalar quantity, velocity is a vector quantity. Speed of a body may be constant, students, but if it changes its direction, then the velocity is varying, and whenever keeping the magnitude constant or the speed constant, the velocity changes, but then definitely there may be an acceleration, because acceleration A is equal to dv by dt. This means if the velocity changes with time, then there must be an acceleration, students. So as this body is moving along the circle, although the magnitude of the velocity, or in other words the speed of the body, is constant, but its velocity is changing at every instant, so there is an acceleration. So the option B, that no acceleration is produced in it, is wrong. Rather, we know that acceleration is known as centripetal acceleration, student, and the force is also known as centripetal force. Okay, this due to this centripetal force, this body rotates along the circle with this radius. So no force acts on it. This is also wrong, because for a body to continue its motion, uniform motion in a circle, a centripetal force is essentially required, students. So its velocity remains constant. This is also wrong, because its velocity is changing at every instant. And what about the work done? Work done, W is equal to, student, we know what is work done. That is it is the dot product of two vectors, force and displacement, students. And this is F as cos theta. We know the dot product of two vectors, and F is the magnitude of force F, vector F, and S is the magnitude of vector S, or displacement. This is the magnitude of the displacement, this is the magnitude of the force, and theta is the angle between force and this displacement. We know every time the centripetal force is always directed towards the center of the circle along which it is moving, student. This is the direction of the centripetal force, and you see every time the displacement is perpendicular to this force. So, student, this cos theta is pi by 2 or 90 degree. So this cos theta is 0, and this Fs cos theta becomes 0, or in other words, work done is 0, because force is perpendicular to student displacement, or displacement is perpendicular to the force. So work done is 0. So we may say option A is correct. No work is done on it, students.